Hello, good afternoon. Brianna Kingdom is my name. Um, I'm going to be continuing what Parabole Mathematics Grade 10 or revision. So if you get this video, you may share it. Sorry, you may share it. And if you want um, personal attention, my number, my business number is 0678908546. I'm gonna repeat it: 0678908546. That is my number. So what we're gonna be doing today, I'm focusing on grade 10. Well, I said parabola. I meant to say functions. Recently I did a video about functions. Started with linear functions, and then I was in parabola, and then probably I'm gonna take it from parabola with some other steps that I left unattended. So I'm gonna attend those, and then continue into hyperbola, and then like that until we finish in exponential functions, and then we go to trig functions as well. So what I'm gonna be dealing with today, let's write functions. So today we're going to look at the parabola. Right, we actually spoke about parabola being in the form of f of x equals ax squared plus q. We actually we explained everything on that. If you feel like you are still left behind about this, you may go to my previous video that I posted about this thing. Right. So when A determines the shape by concavity, and then Q determines it's actually the y-intercept, the same y-intercept, which is also the TP. Only in grade 10, master this. The TP is only this one is only the TP in grade 10, but lately when you get to grade 11 it's going to change, because even the form of the parabola is just going to change. So like this. So now we were actually doing about how do we determine the equation of a parabola. We say there are two cases where you're given the TP and a point. So such that you are going to substitute the TP into the equation. This formula that you're given, right? So probably suppose your TP is 0.8. So already you know that like f of x. I'm sorry, I'm gonna be a little bit quick because other students, they are writing 2 days from now. Yeah, 2 days from now. So I need to get this down in time. So f of x equals a x squared plus 8. Substituting this one into there. So now if you have perhaps another point is 2, 3. Let me use a different number. Let me say -3 temporarily. So now you can substitute this one into the whole thing here. Already you have 88. So now we can substitute this one into this one so that you understand what is going to be the other values. So now substituting this one into this one, you have -3 equals a times 2 squared plus 8. Right now, here you're going to have 4a, dropping everything. You're going to have -3 equals 4a. This is 4, right? A, then plus 8, right? What you need to do here, take this one to the other side. You're going to have -3 minus 8 equals 4a. That's going to give you -11 equals 4a. Right? Dividing both sides by 4 over 4. So you get the value of a equals -11 over 4. Probably sometimes you need to write this thing as it is, -11 over 4. So now what can you do here? You are asked to determine the equation of this parabola. Parabola. So what you're going to have, you have f of x equals, now you have the value of a. So remember it's ax squared. So you're going to have negative equals -11 over 4. And then you say x squared. But here we said we're going to put 8, which is a y-intercept there, plus 8. So this is our formula, our equation of the parabola. Right. So now I think this is understandable. Hey, let's go to the other point. I mean, the other case where you're given at least 2 points. The one that you're given 2 points, you're gonna need to use simultaneous equations. I spoke about simultaneous equations. I didn't explain much about it, but I'm gonna make a session about simultaneous equations. Please, master, this is just revision. In case we may not get time to cover up everything, I'm still going to restart making some videos concerning all this. So let me not talk too much. Probably let me give you at least 2 points. You have 3, 5, and then you have -2, 4. Right. You're given these 2 points, and then you're asked to calculate. I mean, to determine the equation of the parabola. So now, mind you, these points, either of them, none of them actually, neither of them are the value of Q. I mean, are the y-intercept, because you can see this is not the y-intercept. This is either not the y-intercept. Right. So what you're gonna do here, we're going to substitute first with that one, this one into the thing, and then second, this one into the thing as well. So now you know, you're going to say, take this one, you're going to say 5 equals a, now 3 squared. Then plus q, we don't know the value of q. On the other side, you take this one as well. You say on the other side we have 4 equals a minus 2 squared plus q. What do we get at the end? 5 here equals, this is 9a plus q. On the other side we have 4 equals, this is 4a plus q. So with this you can either manipulate this or manipulate that. I actually decide to manipulate this. Alright. Let me check. Let's manipulate that. You are gonna manipulate this one. This is equation 1. This is equation 2. I think I was doing this already, and then we ran out of early cut. So now let's quickly finish this. So let's create equation 3, and then we're gonna put it there. So we're gonna say we're gonna leave q one side. When I have 4 minus 4a, 4 minus 4a equals q. So now this is equation 3, and then putting this equation into that, and then what are we going to have? We are taking this one and plugging it here. We're going to say 5 equals 9a plus, remember they said q, and q now is apparently 4 minus 4a. That's our q. You see, remember here. And then now you actually figure out what we're going to have here. 9 minus 4, that's 5a, right? Is equals to, taking this other one, the other side, probably is going to be negative, is equals to 1. So practically dividing by 5, you'll find that the value of a equals 1 over 5, right? So now when you have 1 over 5 as the value of a, you can take this 1 over 5 and put it there, or either put it the other side. Let's put it here where the value is not that too big. Let's put it that side. So now we have the value of a, but we're asked to determine the equation. Let's come back. We have the value of a. We're looking for q right now. So substituting 4 equals 4 times 1 over 5 plus q anyhow. We don't know what's the value of q, remember. We used that one earlier on so that we can eliminate things. So now we're looking for the actual value of q. So now 4 times 1 over 5. Probably this is 4 equals 4 over 5. Remember, over 1. That's what you're going to have here. 4 over 5. Plus q. Subtract, come this side. 4 minus 4 over 5 equals q. So what can we do here? Multiply this one by 5. So we have 20 minus 4 all over 5 is equals to q. So we have 16 over 5 equals q. 16 over 5 equals q. Now we have the value of q here, we have the value of a here. Let's finish up this thing before it's too late. Now f of x Let me change the marker. I want people to see what I'm actually doing here. If it won't right now, I'm gonna change it. Yeah, f of x equals, remember it's ax squared, so it's 1 over 5 x squared, and then plus 16 over 5. This is your equation. Now you are done. I think I explained on the other side that they'll tell you in the equation how they want the equation to look like, in the form of f of x equals ax squared plus q, or in the form of y equals to x squared plus q. That is that about the parabola. Right. We have this one also, the hyperbola. Before you rest your mind, quickly let's go through the hyperbola. Right, I know I'm too much in a hurry, but I need to get this thing done in time. Right, the hyperbola is of this one. F of x equals, what do you call it? A over x plus q. There we go, a over x plus q, right? So now, with this one, it looks hard, but it's very easy. A, with the value of a, is going to determine which quadrant. You know, a hyperbola is this kind of a function. For example, it's like this, or it's like this. That's a hyperbola, right? So, I'm just showing you the example of how it looks like. So now, I want to wrap this only. I'm left with my thing there. This is y, this is x. Right. With the hyperbola in this form, A determines which quadrant. Remember, in trigonometry, I don't want to dwell in trigonometry right now, but I'm just going to show you that this is 1, this is 2, this is 3, this is 4. And you ask me, why are you counting backward? That's what we do in trigonometry, though I don't want to dwell much into trigonometry at the moment. We are going to see why we do this when you get to trigonometry. I apparently just know that this is 1, and then we go count clockwise. I mean, anti-clockwise, we call it 1, 2, 3, 4. So with the A, if A, and then we write this quickly, if A is greater than 0, which means we'll have this one on the first, let's say, first and third quadrant, right? And then if A is less than 0, then the opposite is true, 2, second and fourth, right? So if A is greater than 0, which means our graph will lie here and here. If A is less than 0, it's going to lie here and here, right? And then we want to talk a little bit, not that much, about lines of symmetry. You know, put it a little bit here. Right. Suppose, let me draw this one and this one, which is already the sketching here, and then I have the point there and the points, those points, right? So now those points, I'm gonna label them quick. Right, let's have that one. And then I know you may be asking me, how am I going to master all that? But I will show you how do you master this. There is this theory right here. We have square root of the roots of this point is square root of a, and then remember we call it x. This is x, and then with y being square root of a plus q. Mind that the plus q is outside, right? And then then on this first quadrant, and then let me go to the second quadrant. On the second quadrant right there, we are going to have a negative square root of a for x, and then for y, we're going to have a positive square root of A, then plus Q. Then you tell me like, how are you going to master all these things? I will show you how to master this. Let's go to quadrant 3. Quadrant 3, we are going to have negative square root of A with a negative square root of A plus Q, right? And then on the last quadrant, you are going to have a positive square root of A with a, this is X, this is Y, and then X here, and then a negative square root A, then plus Q. Right, this is Y as well. Right, and then somebody may be asking, how do you master all this information, which is what we need for us to be able to sketch this kind of a function, which is the hyperbola. Probably, yeah, I know some people, they just use the type method and all that. Yeah, of course it might work, it might not work, but this is the very best way. And then you can always work your hyperbola, and then probably for trying to find the points or whatever on the parabola or something. Then this one, how do you master this? You will have to notice, I keep on going to trigonometry a little bit, but I don't want much there. Notice here on the first quadrant, all ratios of trigonometry are positive. And then, like, I don't want to talk about trigonometry being positive right here, but let's check why are the Alright, why is everything this are positive? Because we see here we have a positive square root of A and a positive square root of A as well plus Q. That's right. Maybe the first thing that you have to master, everywhere Q is positive. Q, right? So it's going to depend with the value of Q. Even if it's negative, then it's going to be negative, whatever, right? But just apparently you write it as positive. And then right here, how do you know that, like, which one has to be positive and which one has to be negative? Right here, you take a look. We say XY. Apparently from here, going that side, X is positive, and then that's why we have positive A here. And then Y as well is also positive right here. I mean, this side is also positive. That's why we have a positive Y here. But then when you come to quadrant 2, repeating the same thing, you'll notice that the X is negative. That's why we have a negative root of A here. But the Y is still positive. So we have a positive root of A right there for Y. And then when you come to quadrant 3, you'll notice that, like, X is negative as well as Y is negative. Hence we have negative A and a negative A plus Q as well. I think that should be making a little sense. And then when you come this side, nice. You notice positive, X is positive. From here going that side, X is positive. Hence we have a root of positive, a positive root of A here. And then, but when you come to Y values are negative this side. So we have a negative root of A, right? Mind you, the negative sign is outside the square root. Remember, with the imaginary numbers, in the real number system, we also have those imaginary real numbers. The imaginary numbers, which are non-real numbers. So something like square root of X and negative square root of S, something like this. This is non-real. But then take a look. This one, the negative, it's outside the bracket. Outside the square root. It's not under the square root. So this is non-real. It's unlike this one. It's all these and these. They are just unlike this. This is a non-real number. So this is basically where we start when we're sketching the hyperbola. And then now, you may also, we are still going to use the same thing. Let me eat a little bit, sorry, I'm hungry. A guy who is choosing and eating at the same time. Alright. Functions are interrelated, sorry, I'm back. Functions are just related from linear function until you get to, I don't know, up to here, it's still the same thing. What did we do earlier on linear functions? We were told that, oh, you're going to use the table method, oh, you're going to use this and that, oh, you substitute. Alright, now, suppose you're given the y-intercept, this point, for intercept, okay. Given this, and then maybe, suppose being 0, 3. right? And then now, and one other point, suppose, one other point. Then what we're gonna do, one other point being 5, 3, 5, 2, whatever, right? So now they say determine the equation of this one. Right, you are now determining the equation. Now there are two ways you can actually determine it, 2 ways, whatever. Alright, you are given this. This is the y-intercept, we can see that. How about this one? Alright, it's just a random point, whatever. So this is easy. You now know you just want to substitute this one first. F of x equals a over x plus q. Right, you know already q is 3. So plus 3. Suppose that was minus 3, that will be minus 3. Anyhow, cool. So this is plus 3. Because that's positive 3. Now we are taking this point, we're done with that. Now we're taking this point that is over there, and then we work out what we were going to have. So we have 2 equals a over 5 plus 3. Whatever. Let's check. Working that, you can take this one the other side. You have mine. Alright, let me work it out. 2 minus 3 equals a over 5. So now you have my 1 equals a over 5. Working out the value of a, right? Equals a over 5. Right? So cross multiplying, you notice that like minus 5 equals a. So now you have a new thing here. Minus 5 equals a. Alright? You got a new thing. So you have f of x equals, now you take this value, minus 5 over x. Remember it says over x. Then plus 3. There you are done. You are very done right there. You have found the equation of a parabola. Oh, this is nice, huh? This is really nice. This is really nice. Right. What else? There is nothing new here. Even if you are given 2 points, let me give you this 2. Even 1, whatever, doesn't matter. Even 1 can work. Right? Remember the simultaneous equations. Let's start with that. 3 equals. We don't know the value of a. Whatever, we don't know the value of a. 1 over 1. A over 1 plus q. 3 equals a plus q. That's equation 1. You come again, you substitute that one, this one into there. 2 equals a over, we don't know the value of a, right? A over 5 plus q. So now, which means you can manipulate this. If you want to work this one further, you can. Yeah, you can. You can work it further. But well, I prefer that you leave it like that and manipulate this one. Right, let's manipulate this one. In terms of what? In terms of q. In terms of a. Whatever. We can say 3 minus q equals a. We've manipulated. This is 2. This is 3. Right. Now take this one and put it there. You have 2 equals a over 5 plus 3 minus, remember, this is a, q. Wait, sorry, I might have made a mistake. I made a little mistake. Let me start it afresh. Let me start afresh quick. What did I manipulate? I manipulated 3 minus q, this one, equals a. And then here I have 2 equals a over 5 plus q. Alright. So probably let me manipulate this other one. Yeah. Let me say minus a equals q. Yeah, I think that's gonna be perfect. Yeah, very perfect. All right. Now I can take this one and put it there. Right. 3 into 2. Yeah, I mean equation 3 into equation 2. Right, so I will have 2 equals a over 5. This a over 5. Then plus this one, which is 3 minus a. That's the value of q, whatever. And then when you are here, probably you might need to work fractions the way you will have done in primary. Let's work fractions this side. 2 equals a over 5 plus I must say 15. So this one 15 over 5 minus 5a over 5. So you can just put one thing here over 5. Then say equals 2 over 1. Say 8 plus 15 minus 5a. So you notice that we still have variables and all that. We can cross multiply now. 5 times 2 with let me start with this. A plus 15 plus it's minus 5a equals this 5 times 2, 10. Alright, we can work now. Maybe we can join these two. Joining this and this, you get to negative 4a. Then you just put equals 10 minus 15. Probably let's just go straight to the point. Minus 5. Because this one and that one, minus 5. Right. Now you can come here, divide by minus 4. And this one is minus 4. Then you have a. Let's hope we have the value of q already. Do we? Oh, not yet. Okay, fine. A equals minus minus equals 5 over 4. This being our a, and then fine, that one will go and then that one will go as well. So now we are left with 5 over 4. All right, this is a, and then remember we asked you to calculate the equation. So it's crazy in another way that I'm finding a fraction which is going to be 5 over 4 all over x. Then let's find the value of q. Let's find the value of q by taking this into that. So I can say 3 minus 5 over 4 equals q. So I can say cross multiply, we have 12 minus 5 all over 4 equals q. So now you know that 7 over 4 equals q. So plus 7 over 4 here, f of x. There is our equation. I'm sorry, we are writing a lot of things, it's mixed up, but f of x equals 5 over 4 all over x plus 7 over 4. That is that. I just randomly thought the equation. I didn't work it out, but that's how it works. Probably if you will understand the simultaneous equations, that is the process that I'm always using right here. Now, let me work out another thing, one more again. We're done with linear function. We're done with parabola. We are also done with the hyperbola. There is the kind of questions, but there is exponential function. Don't forget, exponential function is in the form of f of x equals ab to the power x. Right, but before we get to this one, is it ab to the power x or whatever? But before we get to this one, I want to introduce something like let me draw a function here. Maybe we have something like this. I'm not going to write a question. I'm just gonna remind you such kind of question that they ask in most cases. Have this marker. I wonder if it's working. Alright, let me have my parabola going that way. Right? Then they tend to cut here. They tell you this is f of x and this is g of x. You might have seen something like this, alright? You might have seen something like this, and then they'll be asking some crazy, stupid questions, asking what is this, what is that. Alright, cool, relax. Now, they sometimes ask things like for which values of g of x is whatever they say less than f of x, whatever g of x, which values of is g of x greater than f of x. All right, which values of g of x is greater than f of x, sometimes something like that. So where the question is actually asking, where is g of x greater than f of x, or where is g of x bigger than or above? All right, how do you get to know above? If I say above, maybe it doesn't make sense, a greater sense. All right, I will see how we get to know that. All right, did we notice that like from 0 here going downward, those are negatives, but here we go, our g of x goes that way, cuts here. All right, cut the point here. There's a point somewhere, I don't know why they were paying, you know. And then also there is an intersection there. There's an intersection here. There's also an intersection that side. So, but wow, now which values of g of x is greater than f of x? So greater than f of x, which means f of x. Remember, f of x is this curve going down the side. So all this part you notice. They tend to explain it better in grade 11 and 12. They say the space that is under the curve. So all that part that I showed there, g of x is greater than f of x. Why? Already g of x is above this portion, you know. But this portion that we shaded right here is part of f of x, and that means that g of x is above. It's above that portion, right? So in this point and up to this point, so you will notice perhaps it will be shown that okay, this is maybe this is point 5 here. So if this is 5, you know already here, maybe wait, no, not right there. Maybe this is 4, right? So you know already this. If this is 4 and this is 5, negative 4. If this is negative 4, and then we know that this is positive 4, right? Whatever. But then the point exactly, the coordinate, it's a negative 4, 0. Negative 4, 0. Right? Without, doesn't matter about that. Here also we have a 4, 0, but this is 5, 0. Alright, so, but what matters, our answer, if they're asking that like g of x is greater than f of x, which means we know that from negative 4 up to 5. Negative 4 up to 5. Those are the values, right? So between negative 4 and 5, g of x is greater than f of x. So if they ask less than. Less than is the same thing anyhow. It's the same thing. So that is that, guys. I think that is making a better sense. They tend to combine this thing linear plus job, So all this part is, g of x is, greater than f of x. But then on the same spot again, -4 going the other side. Now g of x is less than, and 5 going the other side, g of x is less than f of x. You see, from here going this side, all this portion, already now g of x is less than f of x. And from here as well, going the other side, now g of x is less than again, less than f of x again, because now f of x is now this part. Remember, what is f of x? This green thing, and this green thing, and this that we shaded is f of x, right? So already, if we are now this side after 5, then g of x is less than f of x. And before -4 also, or up to -4, g of x is still also less than less than f of x. But from -4 up to 5, then g of x is greater than f of x. That's what we are actually saying. This one today I am going to cut myself, and then we are going to meet when we are doing exponential function, and then after exponential function we are going to look at trig as well, sine function, cosine function, and all that tan function. So I think that one is better enough. Thank you so much for your time. My number again, get this link, 0678908546, or let me write it down so that you copy it quickly. 0678908546. That's my number. Thank you so much.